Good morning, YouTube. So we got a Saturday morning stream here. Had a problem setting up, so we also have to tutor a kid very shortly. So I'm going to make today's YouTube a lightning round. Normally we go for an hour or two, but like I said, I have to get out of here. So what I'm going to do is just do my normal kind of one or two problem kind of thing. We might go for about 15 minutes. What I might do is do another YouTube later, and I have to see what's going on about tomorrow, because this is a holiday weekend. Lots of busy stuff I got to have done, so I'm not sure what I'm going to do. Then again, I do streams, I float about. I'm not really about hard, fast things. If you don't know who I am, I'm Greg from GregsTutoringNYC at gmail.com. I specialize in specialized tests, including the SHSAT, and this kind of little snippet of live streaming is appropriate just to bite off a problem or two. I often do this about math, but I have a whole bunch of other streams about other topics as well. So let's jump into the first problem. Let me just make sure it's showing on your guys' screens. Looks like it is. Oh wow, this is pixelated bad. Let's see, how can we best get this? Boo hiss, man. Oh boy. Let's see here. Does that make it any better? I'm going to try to hold this by hand and actually see if I can do this better than that. All right, so we have a trapezoid. I'm going to move the camera back and forth today because this is too much. We have a trapezoid that has a height of 6 feet. There's the little corner piece, which is 2 at the bottom, 4 at the bottom, and then 2 at the bottom. And this over here says D. By my thumb, it says D. This isn't working either. Here, let me try to rewrite these because this is way pixelated, people. So this is 6. This is 2. This is 4. This is 2. And this over here in the corner is D for the depth. All right, actually now it's not coming pixelated, so that's good. So, and I'm going to guess they want us to do the volume here. And I say this in the sense I already read the question, obviously, before I picked this one. You guys need to come up with these same kind of things. That's what you're looking for this for. You're looking for givens, and you're trying to get yourself, like, as if you were the test writer, why would you be presenting this to a bunch of kids? So a bunch of things should leap out as you're looking at this. One might be the area. Maybe they just want the front of it. Maybe they don't. Maybe this is a distraction putting the D here. I don't know. Okay, that's the mode you want to think in here. Or maybe they just want to get the surface area of the front. Or maybe they want the surface area of all the parts. Okay, because they could want the volume or that. So you need to know all these rules. Okay, all right. So that's really all it is. It's a trapezoid with depth to it. So it's a 3D shape. So the words say the end of a tent. So they're calling it a tent, as in it has something like this here. You focus on those lines. The end of a tent has a trapezoidal cross section as shown above. What is the depth of the tent? The volume is 216. So they want us to find D. All right. So for enough kids, this is going to throw you off. Here, let me try to put this in here so it's kind of as flat as possible. So again, we can look at the answers. That's half cheating. So what is the depth of the tent if the volume is 216 cubic feet? Well, normally when we get the volume of something, we're normally trying to get a length times a width times the height. Okay? And another way to look at this is, if, for instance, if this was, say, a rectangle, that's really the area. Okay? So volume in a lot of ways is the area times the height. Or in this case, they're calling it the depth. Okay? So it's really the same thing. So the question is, how do we get, if we have that trapezoid, which they told us was this is 6, this is 2, this is 4, and this is 2. What do we do with that? Okay, that's really what this problem comes down to. So there's two ways to solve this. One is to know how to get the area of a trapezoid, and then we can, in this case, we're going to do that equals the area times the depth, okay? That's what we're striving for, try to get that D. So we know this is 216 already. The question is, how can we get one or the other? We can figure this out from the numbers they've given us. So you either know the area of a trapezoid, which is the area of a trapezoid is the two bases, base 1 plus base 2 over 2 times the height. Okay, so this here is base 1, and this whole thing here is base 2. Okay, and it doesn't matter which one's base 1 or base 2, and for the purposes of this, normally you pick the one at the top and the other, but we could have turned this upside down, and then you're like, wait a second, right? So we can call that base 1 a base 2. So at the end of the day, it doesn't matter. We're just trying to get the numbers. So base 1, if this from here to here is 4, then here to here is 4 as well. So we get 4 plus, we have something over 2, right? I don't know why it's printing that up. Give me 1 second. Let me get rid of messages. Okay, there we go. So base 2 is the 2 plus the 4 plus the 2. So we get 6, we get 8, and we get 12 over 2, and we get 6. And that's going to be 6 times the height, which is 6. So we get 36. Okay, there was another way to do this, which is to get the area of this plus the area of this plus the area of this. We know this is 6 and this is 4, so this one gives us 24. We know this is 2 and this is 4, so we get 1/2 BH, right? So we get 4 times 2 is 8, and we get 4 here, and this is the same, so that's 4. We could have also gotten this is to 24. And taken this triangle, because if we complete this way, we could have put this one here. So we still have 2 by 4, which is the 8 or whatever. All right? In any event, what we're trying to do now that we have that number, we can feed it back into here, which is 216 equals 36 times the D. Okay, and we get divide both sides by 36. So we get D equals that, and that looks like it's 6 times 6 gives me 36, so I'm going to work off that digit. So let's try that out. 36 times 6, 3, 18, 216, and that's what we get. We get 6. So I hope that's one of the answers, and I hope I did my calculations right. And that gives us the second choice here, which looks to be like 6. Let's see what I have. 6 times 6 is 36. Yeah, okay. By the way, I said these are 4. I did my simple math wrong. These are 6. So you get 12 plus 24. 6 plus 6 plus 12, 24 gives the 36. Okay? I said a second. I think the numbers I gave before added up to 32. All right, so that's that problem. So remember, start with your illustration. Don't worry about your words. Almost make believe that these days, because we have grid-in problems on the SHSAT, make believe they're grid-ins. Let me just make sure the stream is going live. Yeah, it is. Okay. Make it a grid-in. Try to solve it as best you can, and then work from there. All right. Okay, so that's that one. So what we're going to do now is flip to a more involved one or a different one. You guys probably haven't seen much of in in a lot of your work. And this is kind of more of an old style question, but it's still game. And if you can get it, it's going to be a leg up for you guys. And even if they don't ask it, it's a good practice question because they may ask it in a slightly different form in the modern days. So what we have is 3 fractions. And there's kind of this giant parenthesis here, from here to here, and another kind of giant one from here, and then a bracket. Okay, so again, I'm starting from the premise again. I'm making believe this kind of fraction thing here, this expression, is my illustration, and I'm just trying to kind of look at it and say, like, what the heck are they giving me now? Because most of you guys have never seen the parenthesis so large, and a lot of you probably never even saw the square bracket. And a square bracket, for the purposes of a test like this, just means the same thing as the regular parenthesis. We have this in normal English writing, when we can parenthesize something, and we can also square bracketize it. They have slightly different meanings, but in here, when you follow PEMDAS, in fact, in like the UK and India and so on, I believe it's RAMIS or something like that, which works from brackets. So they consider the parenthesis part of the bracket system. So what we have is, if we work with our commutative and associative laws of multiplication, there's this whole thing, the first thing, the second thing, and the third thing. And they're all just being multiplied against each other. So it's x over y times a over b times c over d is really what we have here. So we could go across this way and multiply these buggers out, and across this way for the denominator and multiply those buggers out, and it'll still work, but you can get something so freaking ugly that your head's going to explode. So when I see lots of fractions like this, my first inclination is, what can I cancel out? All right? So the first rule is to remember that if I have a over b times c over d times x over y, we can combine the whole thing to a times c times x over b times d times y. And on that note, we can flip any of these on the numerator denominator back and forth, because that's what our identities tell us. So I'm allowed, if this was a 2 and this was a 2, I don't have to just cancel over here. I can cancel from here to here and say these are both 1 now. All right, and I can go across this way in any combination, because when it combines here, I can go up and down then. All right, so if we come back to the problem, we might be able to do that too. So let's just back off a second, because we're still looking at the illustration. So it says simplify this expression, where m can't be equal to n. That's this one here, because if it was, the denominator would be 0, and that's infinity. It's undefined. M is not equal to minus n. M is not equal to minus n squared, because that would make this one 0. And n is not equal to 0, because that one would be 0. So they ruled out all the cases where it could be an undefined thing, so that the integrity of the question is sound. And then we have kind of some weird things here. So if you try to match these at this point directly, you're not going to do this. And as I mentioned in some other YouTubes, sometimes the form you end up after doing this is not the form here. So let's just see where we can go. So first of all, given what I mentioned above here, in the white part, right? I have an n here and an n there. Okay, so that's gone. Okay, I also notice that this says m plus n squared. Well, if I have a plus b, it's the same as b plus a. So m plus n squared is the same as n squared. Wait, sorry, I did that wrong. N squared minus m. And remember, we can go across these different things here. So what we're going to also notice is that these are the same except for a negative. And these are also the same except for a negative. Whereas if we multiply one or the other by -1, right, we're going to flip into the other one. So we can actually do that if we multiply this by -1 over -1. We're going to get these things here flipping back and forth, right? Let me see one thing for a second. Oops, what'd I do? All right, give me 1 second. There's always a technical difficulty. All right, here we go. So the goal is to get these flipped. The where is that again? The n minus m versus the m minus n, and the n squared minus m versus the 1 here. So if we multiply the -1 here times this, we're going to get m minus n squared. Okay, so that's going to cancel this and this. And if we multiply the minus on the numerator, we're going to get this one to be n minus m, which turns out to be this, all right? And that leaves us with the m, which would be e. Okay, I think the minus signs got screwed up with the plus signs here. I believe this one was actually a plus sign here. Where is it? So that would flip the sign back. All right? And everything else cancels out at that point. All right, I'm going to have to go back to the original of this and see what the deal was. But that's generally the premise here. So remember that you can have terms that are flipped, like a plus b is the same as b plus a. Always remember that you can use this -1 kind of trick to flip things back and forth, because -1 over -1 is still 1. So you're not changing the actual formulas and so on this. You're just reorienting things, which is fine. You're allowed to do that. All right? Okay. I'm going to try to pull up the original photo here and see what the actual situation was. Because when I looked at it early, it was a plus sign. So, all right, people, I have to go. I might do another stream later. All right, peace out, and we'll see what's going to happen for tomorrow. And Monday is a holiday too, I guess. So we'll see what's happening then. All right, peace out.